Hello everyone, Farhad here, and we are going to install Postgres using Kubernetes on Kubernetes. So here we go. So to install Postgres on Kubernetes, we are going to use Kubernetes. Well, Kubernetes is basically a controller to deploy Postgres on different namespaces. So mostly this is a standard for third-party suppliers to deploy their pods into Kubernetes. There is one controller in its own namespace, and it will introduce some custom resource definitions to Kubernetes, and then you will deploy with those CRDs, and then this controller will just read the CRD configuration and then will create Kubernetes specific resources. So let's go on and then install Kubernetes. So I will show you like what does CRD means. The good thing about installing Postgres databases in general in Kubernetes is that you will get introduced to a lot of different features that Kubernetes has. And you will get familiar to different concepts, persistent volume, PersistentVolumeClaims, custom resource definitions, which is not specific to databases. Any other third-party suppliers may have this. For example, Dapper have this. You can create your own. And in this case, Kubernetes is from Postgres. And what will happen is that basically we will deploy a resource of kind Kubernetes now. So if I come down here, as you see here, my resource has kind Kubernetes. And the Kubernetes controller, which is this pod here, this one, will find this specification under any namespaces, doesn't matter. And then it will apply this specification. And then the controller will divide this, for example, to stateful sets, to diamond sets, to pods, to secrets, services, and so on. So let's go on and then apply this one too and see what will happen. So let's create a Postgres YAML file. And I'm going to deploy under Postgres namespace, and then the name is going to be PGSQL. Here you can pick the version of the Postgres that you want to install. I want one replica for now, and then the size will be 5 gigabytes. I'm gonna get back to that. And the value will be the value for Postgres password. This is the Postgres user password. I'm going to just set it for now to 123.123. Don't do that for production. For production, use a secret QRF here. So this means that you have to apply a secret with this name and with this key in it. But here, for now, for convenience, we are going to just apply with plain text passwords. So we said we are going to get back to this one. So here's the deal. We are going to right now deploy Postgres on a bare metal server. It's like a virtual machine, which is plain Linux on it. We don't have any provisioner installed on this machine. And what does a provisioner here mean? For databases, especially for persistent volumes and so on, a provisioner means a service which look into your deployment and then check how much space do you need. You say here 5 gigabytes, and then it will go and then request 5 gigabytes from a storage server for you. But in our case, since we are just installing on the operating system itself, like this is bare metal, there's no other layers. This 5 gigabytes is just for the beginning. It's just to compare this from the PVC to the PV. PVC would be the persistent volume claim, and the PV would be the persistent volume. After that, when the persistent volume is exceeded, when the capacity is done, it is full. For example, you have requested 5 gigabytes in the beginning, and then now it is going to use 6 gigabytes. You are not going to have an issue because you don't have a provisioner and you're just running on the disk. It is not limited and it can use as much as it can. But when you are on a cloud environment, for example on Azure, on Open Telecom Cloud, on AWS, you have to be careful because when you request 10 gigabytes, this 10 gigabytes get filled up and then the Postgres service will stop working because it cannot have any more, because there you actually pay for this capacity. And then now you have to increase it and say, hey, I want more. And then that provisioner will read the new requested value, and then will scale it. But that's another topic for another video. But for now, that's it. This is how it's going to work. And now let's actually see how we are going to tell this deployment that we don't have a provisioner. So that's where the storage class name comes in. So let me go into this definition of the Kubernetes, what I have to apply. As you see under the database, I have a property called storage class name. I'm going to copy this, get back here, and then put it here. So let's see actually what do we have as the storage class name. Give me the SCs. The SC is short for storage classes, and I already have local storage. This was not there. This wasn't existing in my cluster. I have added this, and you can actually add this in from here, Kubernetes local storage classes, and it actually I'm actually going to put the links here. So for example, you see this is what I have applied, and this is the local storage. It doesn't have a provisioner, so when we apply this local storage to this Kubernetes deployment, which is local storage, as you see, it says no provisioner. So this means that Kubernetes will not just do anything about this. It is just never mind. And now let's actually apply this and see what do I mean with it's never mind. It doesn't matter. So Kubernetes will not do anything about it. So kubectl apply Postgres. I think we didn't create the namespace. kubectl create ns Postgres, or it's created before. I've created it before. Okay. Let's apply this file. So now, if I go into my Kubernetes, I go under the Postgres namespace. I see a pod is created, but the state is yellow. If I click on it, it says didn't find available persistent volume to bind. What does this mean? It means that it has a persistent volume claim, but the persistent volume claim cannot get a persistent volume. Since we don't have a provisioner and we are using the local storage class name, the persistent volume is not created automatically. So this is where we have to apply the persistent volume ourselves. So let's do that. We are going to create a new file, and then the persistent volume. Here is just good to know that it's good to install the Kubernetes extension in VS Code. It will give you all of these autocomplete templates for the Kubernetes resources. My persistent volume name is going to be PGSQL PV. I will call it YouTube because I already had one before. The size that I'm going to have is 5 gigabytes. The storage class name is local storage, and we don't need the mount options, we don't need the NFS. So what we are going to need is the node affinity. So what does this mean? Since we don't have this provisioner, so the provisioner knows everything. It knows where this storage is, so it will tell the service that you can find it inside this network address or something. But here, since we don't have that, we have to explicitly tell Kubernetes that you can find this persistent volume on this specific node. Otherwise, it will just it won't find it. It won't find it. It doesn't know where to look. So how to do that? It says node selector terms match expressions. I say, okay, my key is Kubernetes IO, and it is the host name. So this is, what key is this? Let's see actually what does it mean. So if I go under my Kubernetes cluster, I go into node, and then here Let me see if the host name. Yep. So I say look for this key in the nodes, and then match the values which matches a specific value, and then it will be like this. So match any host names that are in this values. So there we go. There is one other thing that I have forgotten, and then that's the mount path. Let me see. Local. So the path to my so where am I going to store the data? So that's where you should go to your server. Here I'm already logged into the server. My volume on this server is mounted under this location, and then here I already have some paths, some volumes specified. This one was from the previous videos. Redis is the Redis that I've deployed is using this volume. I'm going to create a new one, so I'm going to create PGSQL and YT, short for YouTube. And now I'm going to say store it under mount volume, and that would be PGSQL YT. So now let's apply this PV. You don't need a namespace. This is here in this case, this is global. It will be applied. It doesn't matter if you add a namespace here. kubectl apply f pv.yaml. Now our persistent volume is created, and now if I go to our claim, as you see, it found the volume. So the persistent volume is created. This is the Postgres PV that we created with 5 GB and with the address that we just added, this one. And yeah, so the persistent volume claimed the volume, and now let's actually see what's happened to the pod. As you see, the pod is also running right now, and now actually let's connect to it. So to connect to this Postgres, before that, let's actually see if it's already stored anything inside here. As you see, the PG data folder is already here, and let's port forward it. So kubectl port forward services PGSQL. The port number for the default port for Postgres, and under the Postgres namespace. So this is our Postgres, and now here we have this extension from VS Code which can show us the databases. Let's actually see password. Yeah, this is from another video, so that password was different. I'm going to remove this and then create a new connection. This is Postgres. This one we added 123 and connect successfully, and now this is our database. So as you see, it was very simple. It even didn't even take to 5 minutes to make a Postgres up and running. But actually, let's see what will happen if I now do this. I'm going to increase it to 2 replicas. I need 2 replicas, and I'm going to apply. This is in case of that you want a high availability for your database. So a new pod is there, but now this new pod also says that, hey, I want a new persistent volume. So in that case, you just go on and then create a new one, and then that would be on this address, and that would be make your PGSQL YT2. And the rest is the same. So kubectl apply f, again pv, and then let's wait to see what will happen to this one now. As you see now, it has also claimed its part, its volume, and now this one should also be fine in a second. Most of the time when it's not, just kill it, and then it will create a new one and it will find its PVC, which is bounded. So let's give it some seconds.
One eternity later.
So as you see, the problem is resolved. The new replica is also loading. We had one mistake, and yeah, we all do mistakes. We did one mistake, and the mistake was that the new persistent volume that we created for the new replica should have the same path as the first replica, because it's just a replica, and if it has a new path, it doesn't make any sense, right? So it should access the same data, and it should open the transaction, manage the transactions on the same data. So with that being said, I just removed that replica. I just moved it back to one replica, and then removed the persistent volume claim and the persistent volume that I created before, because the path is read-only, you cannot change it. And then moved it back, increased it back up, and created a new persistent volume with the same path as the first persistent volume, and then it started working. So as you see, it's just one service and one service for the replica, but you're going to just need this one PGSQL service. With that, that's it for this video. That's how you install Postgres on Kubernetes when you need to. Normally it's better that you run it on a relational database service on your cloud environment or outside of Postgres, but when there is no other choices, it is okay to just put it inside Kubernetes, but make sure that the storage space that you have your data stored on is safe. So that's it. Don't forget to like and subscribe, and until next time.